Alright, so for today we're going to cover a couple of things in this lesson. We're going to talk about percentiles, dealing with statistics, and we're going to go into talking about introducing Z-scores and how that plays out. So with this data we have right here that's listed in front of you, there is a sample size of 20. There's 20 values there that we have above. Out of those values, the mean is 80 and the standard deviation is 10. So with this, going on percentiles, so we're going to start out talking about percentiles. Okay, so percentiles. Let's think about this. So let's look at the value 60 here. Let's say, I don't know, let's say Chad got the score 60 on this test. We'll count these, we'll say these are scores, okay, for like a quiz or something. So say Chad got a 60. So what percentage of scores are less than 60? Well, there are 3 less than 60, right? So with that, to find that, we would simply say there is 3 out of 20, in which case I'm going to just go to our Google calculator, say 3 divided by 20, that should give us 0.15. So 0.15. So therefore, that equates to the 15th percent. Okay? So in other words, 60 was in the 15th percentile for this. Let's pick another value. Let's go with something high here. Let's say we got the value of, let's go with 90. So how many scores are less than 90? Well, since these are the top 2 up here, I'm going to say there is 18 out of 20, right? So and if that was to be 18 divided by 20, come on, put 18 in there, there we go. And let's go ahead and say 18 divided by 20 is 0.9. Or you can probably understand that is 90%. So in other words, whoever scored the 90 on this actually fell in the 90th percentile. Now that's just coincidence that those values are the same as far as 90 score in the 90th percentile. But in that case, that is how you determine percentile, the saying in your percentile. So again, both of these are percentiles, okay? So let's look at this a different way. So we said our mean, I'll say look at it a different way. We'll look at a different topic, shall we say, right now. We'll say our mean that we had was 80 and a standard deviation of 10. Well, if we took that value of 60, right, we said 60 was our first number we looked at here. So if we take that value of 60, how far away from the mean is it? How far away from the mean is it, and in which direction would you think? So, of course, we would simply say 80 minus 60 and we get 20, right? So it is going to be, for the value of 60, we're simply saying it is 20 below the mean. Okay? Alright, so, and how many standard deviations away from the mean is 60? Well, we have standard deviations of 10. And if we know it's 20 below, so to find out our standard deviations, we simply take our 20 divided by 10, which should give us 2, and that is going to be 2 standard deviations. So 2 standard deviations away from the mean. Okay? Let's think about our other number we looked at. Let's think about the number 90 now. So if we had the value of 90, okay, the value of 90, how far away from the mean is that value and in which direction? Well, hopefully you understand and can see that's 10 above the mean. Okay. And with that, how many standard deviations away is that? Well, we know we went 10 above. The value of our standard deviation is 10. So we know that's 1 standard deviation. So looking at that, yes, right now the way you're looking at it and thinking about it probably is what we had above 60, that was 2 standard deviations away. So should it be -2 or something like that? Yes, so you can say that is -2 standard deviations away, is a -2, and we'll get into a way to say that in the Z-score process, but for right now we're just looking at standard deviations because the standard deviation value is 10. So in other words, 60 is just 2 standard deviations away from the mean, and 90 is 1 standard deviation away from the mean because 80 plus 10 is 90. So that was only 1 standard deviation away. When we get talking about our Z-scores, it'll make a little bit more sense as far as determining which direction away from the mean it is, okay, when you're just talking about standard deviations. Well, let's do one more here to see, because standard deviation doesn't always have to be equal to a whole number here, right? So let's look at the value of 87. So 87 here, look at this value right here. So if we take the value of 87, all right, how far away from the mean is that and in what direction? Well, it is 7 above. Okay? So in this case, we know that we have 7 divided by our standard deviation, which is 10. So that should give us simply a 0.7. Okay? As far as our standard deviation. So again, standard deviation doesn't always have to be a whole number. Again, you're taking how far away whatever value you have is away from the mean and dividing by the standard deviation amounts. Okay? So with looking at that, now that we've calculated these and dealt with percentiles, let's look at talking about our Z-score, okay? So with your Z-score, your Z-score is going to equal the number of standard deviations. So this number of standard deviations away from the mean. So number of standard deviations away from the mean. Okay, so that's what your Z-score tells you, the number of standard deviations away from the mean. Okay, and for the equation for Z-score, our equation for the Z-score is Z equals your value, your x, minus your mean, x bar, all divided by your standard deviation. Okay, so your standard deviation, in which case you'll probably see it in the calculator very often as far as being an SX, right, for your standard deviation. Okay. So with this, let's think about that. With these values we looked at up here, we said this is 2, well, so we said, I'm sorry, this value of 60 was 2 standard deviations away from the mean. So in other words, the value of 60, different color here so I don't get them all mixed up. So the value of 60 would be a z-score of 2, but we said it was below. So therefore it is negative 2 standard deviations away, right? So it's a z-score of negative 2. With a value of 90, we said that that was 1 standard deviation away. And because we said it was above, we're simply say it's plus. And so that should be easy to understand here. For the value of 87, we said that the value of 87 was 0.7 standard deviations away, and because it was above, it's simply be a plus. Okay? So that's what you need to take away from the z-scores right now as far as what they're referring to. Again, the z-score is referring to the number of standard deviations away from the mean. And the equation that you need to be familiar with is your z is equal to your x value, the number that you're dealing with, minus the mean, divided by, all of that divided by your standard deviation. Now, one other thing we're going to talk about here that I wanted to cover too is with percentiles is when we're looking at the box plots. Now, I may have mentioned this in a previous setup as far as 50% within the IQR. The data falls within there, so that may be a little confusing. Didn't quite understand what I was grasping at, but that goes on to the percentiles. So we'll explain this a little bit. So from the min to Q1, 25% of the data is to be within there. From Q1 to the median, 25%. From the median to Q3, 25%. And the last quarter of data is going to fall between Q3 and the max at 25%. And that is how it's always going to be with doing your 5-number summary. When you find that out and you draw out your box plot, even though you have outliers and whatnot going here, what this is saying is the percentiles are going to fall within there. If you're in the 25th percentile, you're up to the Q1, right? If you're in the 50th percentile, well, then you're up to the median. 75th percentile, you're going up to Q3. And then if you're in the full 100th percentile, then you're at the max right there for that one, right? So again, that goes to 20, 25, 50, 75, 100. Each one of those brackets, or gaps to say, between the min, the Q1 to median, median to Q3, and the Q3 to max, is going to be worth 25%. So in other words, the 25th percentile. So that is what's going to hold your data. Or I'm sorry, that's what's pertaining to how much data is being held between those values. So that's why I say, when you look at your IQR, that is containing 50% of your data, and it's the bulk of your data in the middle point, right? So that's why IQR plays an important role in the calculations and moving forward with statistics and how data is determined to be an outlier and what is considered to be within the scope of the data range. So I hope that makes a little bit more sense. I'll see you guys next time.